Have you ever wondered why the equator is a rainforest? Why the Sahara sits right at 30 degrees north? And why massive storms happen around 60 degrees? It's not random. It's the result of three powerful, invisible engines that move air around our planet: the Hadley Cell, the Ferrel Cell, and the Polar Cell. Let's break down how they work and how they shape the world we live in. It all starts at the equator, the part of Earth that receives the most direct sunlight year-round. You might think this constant heat would create vast deserts, but here's the twist. One of the hottest places on Earth isn't a desert at all. It's a rainforest. The equator is home to the Amazon, where temperatures soar, but it rains almost every single day. Why? Because the heat causes moist air to rise. As it rises, it cools, and moisture condenses into clouds. The result? Heavy daily rainfall. That's why the equator is covered in thick, steamy rainforests, not dry wastelands. But that rising air doesn't stay put. It moves north and south high in the atmosphere and eventually sinks around 30 degrees latitude. And here's the catch. The air that sinks is bone dry. It lost its moisture at the equator. That's why some of the world's largest deserts, like the Sahara and the Arabian Desert, are found right around 30 degrees latitude. That whole loop of rising wet air at the equator and sinking dry air at 30 degrees, that's the Hadley Cell. Now let's move up to the Ferrel Cell, between 30 degrees and 60 degrees latitude, the zone many of us actually live in. Unlike the Hadley Cell, the Ferrel Cell doesn't follow a simple pattern. It's more like a middle child, caught between two stronger siblings, the Hadley and the Polar Cells. But don't underestimate it. It's here that weather is born. At the surface, air flows from 30 degrees towards 60 degrees, but because of Earth's spin, it curves and becomes the westerlies, the winds that blow from west to east. These winds are the reason why storms move across North America, Europe, and China from the west, not the east. But the real action happens at around 60 degrees latitude, where warm air from the Ferrel Cell collides with cold polar air. This zone is called the polar front, and it's one of the most chaotic places in the atmosphere. Here the atmosphere becomes unstable. Warm air wants to rise. Cold air wants to sink. The clash creates powerful low-pressure systems, spinning storms, cold fronts, and jet streams that race across the sky. In fact, almost every rainstorm, snowstorm, or cold snap in the mid-latitudes traces its roots back to this battlefront between cells. So if you've ever wondered why the weather changes so fast where you live, sunny one day, stormy the next, it's not just bad luck. It's the Ferrel Cell, constantly negotiating between tropical warmth and polar chill. Finally, at the top and bottom of the world, the polar cells. At the poles, the air is cold and heavy. It sinks, creating high-pressure zones and dry, icy deserts like Antarctica. That cold air moves toward the 60-degree zone, where it meets warmer air from the Ferrel Cell. This collision zone, the polar front, is where blizzards and Arctic storms often begin. These three cells, Hadley, Ferrel, and Polar, work like giant gears, circulating air from the equator to the poles and back again. They explain why. Rainforests grow at the equator. Deserts form around 30 degrees, storm belts dominate 60-degree latitudes, and icy winds sweep the poles. Without these cells, Earth's climate would be chaos. So next time you step outside and feel a breeze, or see a storm rolling in, remember it's part of a vast global system that's always in motion, quietly shaping where we live, what we grow, and how we survive. Subscribe for more videos that turn complex science into simple wonder, and let us know in the comments. Which climate zone do you live in?